Hello everyone, I am Gagan Ladda. I hope you all have done your GATE very well. Students, any exam if analyzed properly teaches us a lot for the upcoming exam. So in this particular series of lectures we are going to discuss about GATE 2016 question paper. We will analyze this question paper subject wise, we will solve the questions, we will get the answers, we will talk about the mistakes which the students are making. And in this particular video, this is the first video of the session. In this particular video we are going to discuss about set 1, and in that particular set we will discuss about strength of material and engineering mechanics subject. Okay, if I go to analysis part, from this particular subject in set 1, total number of questions asked were 13, and out of which there were 6 1 mark question and 7 2 mark question. Total marks is 20, which is a lot from these two particular subjects. Okay, now we will solve the questions of these subjects from set 1 GATE 2016 mechanical. First is question number 6. A rigid ball of weight 100 Newton is suspended with the help of a string. The ball is pulled by horizontal force F such that a string makes an angle 30 degree with the vertical. The magnitude of force F in Newton is. Okay, so we have a string and a ball is attached with this string. The weight of the ball is given as 100 Newton. We are applying a horizontal force. With this force we have to determine, okay, and this string is making an angle 30 degree with the vertical. These are the given figure. Now if I draw the free body diagram, at this particular ball the forces acting are, first is this horizontal force F, second is this vertical force 100 Newton, and third is the tension along the string, which is T. Okay, now what about the angles? This angle is 60 degree, sorry, this angle is 30 degree, so this angle will be 60 degree, this angle is 60 degree, so this whole angle will be equal to 90 plus 60, which is equal to 150 degree. First thing. Okay, again here this angle will be 30 degree, this whole angle will be 30 plus 90, which is equal to 120 degree. Okay, and this angle is 90 degree, as can be seen from the figure. Now applying Lami's theorem here, what does Lami's theorem says? This F upon sine of this angle, opposite two forces के बीच का angle, उनका sine, that means F upon sine of 150, this should be equal to 100 upon sine of 120. Okay, or you can say F is equal to 100 into sine 150 upon sine 120. This is F is equal to 57.73 Newton. Answer. Getting this? A very simple question asked in 1 mark. Next, question number 7. Okay, here is the question. A point mass m released from rest and slides down a spherical bowl of radius r from height h as shown in figure below. The surface of the ball is smooth, no friction. The velocity of the mass at the bottom of the ball is. Okay, again a very simple question. We are having a ball, a mass of a mass m, a point mass m. Okay, and this is a slide in a spherical ball. Okay, at this particular point we are having, at this particular point when the mass is here at a height h, we are having a potential energy. Mass is having a potential energy. Okay, when mass slides down here at this particular point, the mass is just having a kinetic energy and no potential energy, and because no energy is lost in friction, that means whole of the potential energy here will be converted into kinetic energy. Okay, or you can say the potential energy here is mg into h. The kinetic energy here will be half mv square. This mm gets cancelled out, you will get v is equal to under root of 2gh. Okay, so answer is C, under root of 2gh. Getting this? Next is question number 8. Okay, next is question number 8. The cross section of two hollow bars made of same material are concentric circles as shown in the figure. It is given that R3 greater than R1 and R4 is greater than R2 and the areas of the cross section are same. J1 and J2 are torsional rigidities of the bars on left and right respectively. The ratio of J2 by J1 is, okay, so we have this two cross sections given of two different hollow cylindrical bars. First is having internal radius R1, external radius R2. Second is having internal radius R3 and external radius R4, such that R3 is greater than R1 and R4 is greater than R2. This is given in the question. Apart from this, the torsional rigidities are given. Torsional rigidities, that means J1 is given, the torsional rigidity of this is given, which is equal to G into IP, IP1. IP is what? Polar moment of inertia. Here J2 is given, which is equal to G into IP2. So torsional rigidities are given, which are J1 and J2. We have to determine the ratio of J2 by J1. Okay, so what will be J2 by J1? Material is same, that means G will be same, this G will get cancelled out, this J2 by J1 will be equal to what? IP2 by IP1. Okay, or you can say, what is this IP? Polar moment of inertia, which is pi by 32 d outer raised power 4 minus d inner raised power 4, and in terms of radius it will be pi by 2 into outer radius raised power 4 R2 raised power 4 minus R3 raised power 4 upon pi by 2 into R2 raised power 4 minus R1 raised power 4. Getting this or not? Okay, so this pi by 2 gets cancelled out, and we will get here, this will be equal to R4 square minus R3 square, R4 square plus R3 square upon R2 square minus R1 square, R2 square plus R1 square. Okay, another thing given, the area is same, and because the area is same, therefore pi r square, pi into R2 square minus R1 square is equal to pi into R4 square minus R3 square. This pi gets cancelled out. R2 square minus R1 square is equal to R4 square minus R3 square. So this term will get cancelled out. Okay, so J2 by J1 will be equal to R4 raised power 4 plus R3 raised power 4 upon R4 square plus R3 square upon R2 square plus R1 square. And according to given condition, this R4 is greater than R2 and R3 is greater than R1. Okay, therefore obviously this J2 by J1 will be greater than 1. Okay, so answer is A. That's it. Getting this or not? Okay, next is question number 9. A cantilever beam having a square section, having a square cross section. We are having a cantilever beam having square cross section of side A is subjected to an end load. If A is increased by 19%, the tip deflection decreases approximately by. Okay, so we are having a cantilever beam of a square section. The side of a square is given as A. Okay, and the load is applied at the end of this cantilever beam. Suppose P load is applied at the end. Okay, if this A is increased by 19%, then how much deflection will be decreased? Okay, so we know what del is equal to what? In case of cantilever beam subjected to point load at end, del is equal to PL cube upon 3EI. Okay, only the cross section, only the side is getting changed. That means P is same, L is same, E is same. Okay, therefore del 2 by del 1 will be, del is inversely proportional to I, therefore del 2 by del 1 will be equal to what? I1 by I2. Okay, now what is I1? Moment of inertia, area moment of inertia. So this will be equal to A raised power 4 by 12. What will be I2? I2 क्या होगा? तो उसमें the A is increased by 19%. Okay, so this will be 1.19 of A to the power 4 upon 12. This 12 gets cancelled out, and you will get here as 1.2, approximately 1.2. Actually this is 2.005. So this del 2 is equal to 0.5 of del 1. Getting this? Therefore the deflection is decreased by approximately 50%. Answer is D. Getting this? Okay, next question number 12. The spring constant of a helical spring does not depend on. Okay, now spring constant of a helical spring, if I look at the formula, the spring constant K is equal to what? GD raised power 4 upon 64 R cube N. Okay, now just look at the option. Coil diameter, this is depending on coil diameter. Yes, sorry, this is depending on coil diameter. Next is material strength. Material strength पे depend नहीं कर रहा है. Okay, this G is actually modulus of rigidity. Okay, so this is not depending on material strength. Next is number of active turns, this is depending on N, and next is wire diameter, this is depending on small d. Okay, so answer is B, not depending upon material strength. Getting this? Next question is question number 20. Now, what does question number 20 says? The Jomini test is used to find. Jomini test. Okay, this Jomini test is used to find the hardenability of the material. Okay, now hardenability is not hardness, don't get confused with hardness. Hardenability is not hardness. Hardenability is actually the ability to get hardened for a particular material, the ability to get hardened for a particular depth under particular set of situation. That is known as hardenability. And for this we use this Jomini and quench test. The full name of this test is actually Jomini and quench test, which is used to determine the hardenability. So the answer is B. Next is question number 30. A block of mass m rests on an inclined plane and is attached by a string to the wall as shown in figure. The coefficient of static friction between the plane and the block is 0.25. The string can withstand a maximum force of 20 Newton. The maximum value of m for which the string will not break and the block will be in static equilibrium is dash kg. Okay, so we have this question. We have a mass which is on an inclined plane with horizontal at an angle theta. Coefficient of friction is given as 0.25. Maximum force which the string can withstand is given. That means T max. The value of T max is given as 20 Newton. Cos theta is given as 0.8. Sin theta is 0.6, and G is given as 10 meter per second square. Okay, we have to determine the value of this m, mass m. This mass m we have to determine. Okay, now first thing we have to draw the free body diagram of this particular mass. This mass is inclined at an angle theta from horizontal. This angle is theta. Okay, what are the forces acting? First is this tension force T. Second, this mass is trying to move downward, so the friction will act in opposite direction. How much friction will act? Mu into n, where n is this normal reaction. This normal reaction is n. Okay, and apart from this, a mass, a weight, a downward weight will act because of this mass mg. Okay, now we don't have to do anything, we just have to resolve this. Okay, we just have to put the force equilibrium. Okay, now in this direction, in the direction of n, okay, this n will be equal to total upward force is n, and downward force will be equal to, because this angle is theta, this angle will be theta. Okay, so this n will be equal to mg cos of theta. Getting this? This is equation number 1, suppose. Now next, in this direction, in the direction of t, so here t plus mu into n, t plus mu into n will be equal to the component of mg in this direction, in opposite direction to t. So this will be equal to mg sin theta. Now just put the values. This t is given as 20 Newton, maximum value of t is given as 20 Newton, plus mu into n. So mu into n is what? Mg cos theta is equal to mg sin theta. Okay, now put the values. This will be 20 plus mu is given as 0.25, m we have to determine, into 10 into cos theta is 0.8 is equal to m into 10 into 0.6. Okay, and on solving this we will get mass as 5 kg. Answer. Getting this? Okay, next question number 31. Okay, next is question number 31. The two member truss PQR is supporting a load W. The axial forces in the member PQ and QR are. Okay, So this is the figure given, and at this particular point Q, a vertical force W is acting. Here PQ is acting, and here PRQ is acting. Getting this? Okay, we have to determine the value of PQ and PRQ. Same thing, again we can apply Lami's theorem. How can we apply Lami's theorem here? Same, this angle is 30 degree, this angle is 60 degree, this is complete 90 degree, so this angle will be equal to 270 degree. Getting this? Okay, now apply Lami's theorem. W upon sine 30, W upon sine of this angle is equal to PRQ upon sine of 270. That's it. Okay, now just put the value. We will get what? This P2 will be equal to, or sorry, this PRQ will be equal to minus of 2W. This is PRQ. Similarly, we can get the value of PPQ. W upon sine 30 is equal to PPQ upon sine of 60. Okay, so from here we can get the value of PPQ, which is equal to root 3W. Okay, so answer is B, root 3W tensile and 2W compressive. Answer will be B. That's it. Next is question number 32. The horizontal bar with a constant cross section is subjected to loading as shown in figure. The Young's moduli for the sections AB and BC are 3E and E respectively. For the deflection at C to be 0, the ratio of P by F is. Okay, so we have this question, this particular bar ABC divided into two part, AB and BC, each of length L, and the force is applied here is F, and here the force, compressive force applied is P. Okay, total deflection at C is equal to 0. We have to determine the ratio P to F. Okay, now if I want to determine the deflection at C, what is deflection at C? The total deflection at C is equal to deflection at AB plus deflection of BC, deflection of AB part plus deflection of BC part. Okay, or you can say PL by AE of AB, formula we know for del axial load, PL by AE, so PL by AE for AB plus PL by AE for BC. Okay, now just put the values. Now how to analyze this force P? How to analyze this P? This P is actually, this is force of AB and this is force of BC. Okay, now in order to get PAB, what will be PAB? This will be equal to total force acting is what? F minus P. कोई भी एक साइड का देखो, या तो पूरा राइट देख लो या तो पूरा लेफ्ट देख लो. ओके, सो वी आर लुकिंग एट दिस total right F minus P tensile, this much tensile force. Okay, now PBC will be equal to what? PBC, and this only F is acting. Okay, so just put the values. So this will be equal to F minus P into L upon area is A, let's suppose A, and E is 3E plus this P is F into L upon A into E, and this total deflection at C given is 0. Okay, now this A gets cancelled out, E gets cancelled out, and L gets cancelled out. From here you will get what? This F upon 3 minus P upon 3 plus F is equal to 0, or you can say 4F by 3 is equal to P by 3. This 3 gets cancelled out, or you can say P by F is equal to 4. So the ratio of P by F is nothing but 4. Answer. Next is question number 33. Question number 33. The figure shows the cross section of the beam subjected to bending. The area moment of inertia in mm^4 of this cross section about its base is. Okay. This particular question I want to clarify that the question which ISC Bangalore has released in its official website is like this. Okay, but few of my students were telling that the actual question which they are getting in their response sheet, in that actual question this total depth was 10. Okay, so I am just solving this according to the question released by ISC Bangalore. Okay, so we will solve this and we have to determine the area moment of inertia about base. Base के about इस particular section का area moment of inertia हमको निकालना है. Okay, so how can we get area moment of inertia? This total I will be equal to, so how can we get this? This can be taken as a complete rectangle minus a complete circle. Okay, तो हम क्या करेंगे, इस complete rectangle का निकालेंगे centroid के about and we will transfer that here according to by using parallel axis theorem. Then we will subtract this moment of inertia of this circle, a complete circle, semicircle plus semicircle, a complete circle, and again we will transfer this to base by using parallel axis theorem. Okay, so what will be moment of total moment of inertia? This I will be equal to rectangle का क्या होगा 10 into 20 cube by 12. This is total moment of inertia of this whole rectangle. Okay, इसको transfer करते हैं plus a into d square. Okay, so area is what 10 into 20 into d is how much 10. Okay, हमको जो मिला है वो इस centroid के about मिला है, इसको करना है यहाँ पर transfer. So this distance is 10, so this will be equal to into 10 square. Getting this? Minus what? अब इस circle का निकालेंगे. Okay, and what is the moment of inertia of circle? Pi by 64, d raised power 4, diameter is given as 8 raised power 4. Okay, plus अब इसको transfer करो, area that means pi by 4 into d square into 10 square, area into distance square. Okay, so on solving this you will get here this I will be equal to 6465.6 plus 14973.45, or this I will be equal to 21439.05 mm raised power 4. This will be the answer. Getting this? Okay, next is question number 34. Okay, it is given that P is equal to 1 Newton, L is equal to 1 meter and Young's modulus E is equal to 200 gigapascal. The cross section is a square with dimension 10 by 10 mm. The bending stress in Pascal at a point P located at the top surface of the beam at a distance 1.5 L from the left end is. Okay, so this is the figure given. The P is given as 1 Newton, length is given as L is given as 1 meter, E is given as 200 gigapascal. Okay, the cross section is a square, so this is the cross section, a square cross section of 10 by 10 mm dimension. We have to determine bending stress at point A. Okay, now what is the bending stress? Bending stress is equal to what? M by I into Y. So very first thing we have to determine moment at this particular section where point A lies. Now suppose the reactions at these points are RP and RQ. Now we have to determine the moment at M. For determining moment at M, we have to first determine the reactions. Okay, so for that take moment about P as 0. Okay, so this will be RQ into 3L minus P into 2L plus P into L is equal to 0. And from here we will get the value of RQ. This RQ will be equal to P by 3. Getting this? Okay, now get the value of moment at A. The moment at A we can determine now RQ into 1.5 L, or you can say 3 by 2 of L minus P into 1 by 2 of L. Getting this or not? Okay, just put the values. So this MA will be equal to what? RQ is given as P by 3 into 3 by 2L minus P by 2 into L. This 3 gets cancelled out. PL by 2 minus PL by 2. So this moment at A is equal to 0. Okay, and because moment at A is equal to 0, therefore stress at A will also be equal to 0. That's it. Okay, next is question number 38. The principal stresses at a point inside a solid object are sigma 1 is equal to 100 megapascal and sigma 2 is equal to 100 megapascal and sigma 3 is equal to 0 megapascal. The yield strength of the material is 200 megapascal. The factor of safety calculated using Tresca theory or maximum shear stress theory is NT, and factor of safety calculated using von Mises or maximum distortion energy theory is NV. Which one of the following relation is true? Okay, so in this particular question we have to determine the relationship between factor of safety, which is derived from maximum shear stress theory as well as from maximum distortion energy theory. Okay, now what does maximum shear stress theory says? What is maximum shear stress theory? This is tau max should be less than or equal to SYT upon 2N. This is maximum shear stress theory. This is actually yield stress in shear, which is equal to SYT upon 2. So this is equal to SYT upon 2N. Okay, now what is this tau max? Sigma 1 and sigma 2 are given. Sigma 1 is equal to sigma 2, which is equal to 100 megapascal. This is given, and sigma 3 given is 0 megapascal. So what will be the maximum shear stress in this particular case? If I plot this in Mohr circle, okay, so this point is sigma 1 and sigma 2, which is equal to 100 megapascal, and this is sigma 3, which is equal to 0. Okay, and if I draw the circle between these two, maximum shear stress is nothing but the radius of this circle. This is tau max. Okay, and what will be tau max here? The radius will be equal to 100 by 2, which is equal to 50 megapascal. Okay, so from here we can get the value of this tau max first thing. Okay, so tau max is, we have determined as 50 megapascal is equal to SYT is given as 200 megapascal upon 2 into NT. Okay, so from here we can get the value of NT, which will be equal to 2, first thing. Similarly, according to maximum distortion energy theory, what maximum distortion energy theory says? Under root of sigma 1 square minus sigma 1 sigma 2 plus sigma 2 square is less than or equal to SYT upon N. Okay, and N here is NV. Getting this or not? Okay, so from here we can get the value under root of 100 square minus 100 square plus 100 square is equal to SYT, which is 200 upon NV. So this will be equal to NV will be equal to 200 upon 100, which is equal to 2. Okay, we have to determine the ratio, that means NT here is equal to NV. So answer is C. That's it. Getting this? Now last question is question number 48. Okay, what this question says: a hypothetical engineering stress strain curve is shown in figure, has three straight line PQ, QR and RS with coordinate P as 0, 0, Q as 0.200, R as 0.6140 and S as 0.8130. Q is the yield point and R is the ultimate tensile strength point and S is the fracture point. We have to determine the toughness. Okay, now how can we determine this? Is this particular figure is given. This is a hypothetical stress strain diagram. Okay, engineering strain is given in percentage. This is not the value given, this is the percentage of strain given, and engineering stress is given at every point. Okay, we have to determine toughness. And what is toughness? Toughness, as we know, is the area under stress strain diagram up to fracture. That means fracture तक की जितनी energy store करता है, that is nothing but toughness, and that is actually the area under stress strain diagram. So in fact we have to determine this total area. That means area 1 A1 plus A2 plus A3, this total area we have to determine. Okay, now simple geometry है क्या? Area of 1, which is a triangle, so this will be equal to half into 100 into, this is 0.2%, so this will be equal to 0.2 upon 100 plus area of 2, this is a trapezoid. Okay, and how can we determine the area of trapezoid? Half of W1 plus W2 into L, so this will be half of 100 plus 140 into L is how much? 0.6 minus 0.2, which is equal to 0.4 upon 100 plus third area, again a trapezoid, half 130 plus 140 into 0.2, 0.8 minus 0.6, 0.2 upon 100. Okay, so from here on calculating this you will get 0.1 plus 0.48 plus 0.27, so this will be equal to 0.85. Answer. Getting this or not? Okay, so this completes strength of material and engineering mechanics part. One question of theory of failure we also included in this, that actually belongs to machine design, but that was a single question, so we included in this strength of material, and that is something related to strength of material concept only. Okay, thank you. See you in the next video.